Okay, so this is learning target number 4. Now the first thing that I'm going to show you, and I showed you this on the video last night, is this page right here. You'll remember it. It'll look very familiar here in a minute. Okay? Does this all look familiar?
Yep.
Okay. Now, this is it's a bar, but we call it a strip. Same difference. Okay? What do we know that the whole entire strip always represents? 100%. It represents the whole, the total. So, let's say that Caden had $60 at home. Could I make it to where this whole strip equals $60?
Yeah.
Sure. If he had $1 at home, I could make the whole strip worth $1. So it can be anything. It's just about a whole. You guys see what I mean there?
Yeah.
Okay. So it's all about whole and part. Everything you're going to do in this with proportions, we're going to get to proportions next targets. It's always going to be this. This is called a percent proportion. Part over whole equals percent over 100. Everybody understand that?
Yep.
Okay. Because we know that aren't percentages all part to whole fractions or ratios? Yes. Yes. I mean, up 90%, that's part of it to the whole, which would be 100. Okay? All right. Now, the idea is to break your strip diagram, or your bar model, however you want to say it, but I'm going to call it a strip diagram. And you want to break it into evenly sized sections. So can I take this strip diagram and can I cut it like this?
No.
No, because that wouldn't give me an even amount of percents. It might give me decimal percents, but we don't want to mess with that, do we?
No.
So basically, there are only 1, 2, 3, 4 methods that you can cut a strip diagram up into. Now, technically, you can cut it into more than that. If I cut it into 10 sections of 10%, can I do that?
Yeah.
Can I cut it into 5 pieces of 20%?
Yes.
Yep. Can I cut it into 4 25% sections?
Yeah.
Can I cut it into 2 50s?
Yeah.
Okay, now those are the only ones you're going to use. Really, these 3 are the main ones. So this one, and this one. Those are the 3. This one even really isn't all that helpful. Okay? Could I also cut it? Could I make a bar and actually cut it into 20 sections of 5%? Could I do that? Could I do it in 25 sections of 4%?
Yeah.
Could I do 100 sections of 1%?
Yeah.
Sure. But obviously, do you want to really have to do that?
No.
No, that's a pain. We're not going to mess with that. So this is the only way you're ever going to cut a strip diagram up. You're going to cut it into 50-50, 25-25, 25-25, 20-20, 20-20, 20% or 10% sections. Everybody cool with that?
Yeah.
All right. Now, going back to here now. We're going to read through here together. You guys, you tell me if there's anything important that you think I should be underlining. The band has saved $4,500. You think that's important?
Yeah.
Okay, so I'm going to underline it. Okay. So somebody tell me, what is 4,500 representing? No, hang on. Not necessarily true. I'm not looking for part or whole. It seemed like I was going to be asking for that, but I was more just asking that's representing the amount they saved. Do you guys agree with that?
Yeah. Yep.
So I'm going to write the word saved because that's how much the band is obviously saved. Does that say sand?
Yes.
I'm fairly sure I just said sand and not saved. Okay. All right. I don't know what happened there. Saved. Okay, so I just know that's how much they've saved. It doesn't mean it's the part, doesn't mean it's the whole. We'll get to that later. So that's how much they've saved for their upcoming field trip. This accounts for only 60% of the total cost. Do you guys think that's important?
Yeah.
Obviously. The percent's always important. Now it says, what is the total cost of the field trip? Do you think that's important?
Yes. Yeah.
Okay, so that's what I would call the real information. Right? So that's obviously important. That's the question it's asking. We want to somehow, from the strip diagram, we want to be able to figure out how much their trip costs in total. Now, what do I know about this trip diagram right away? What's the first thing that I should know about it right away? Yes? Wait a minute. No. Doesn't the whole strip represent 60%? Yeah? And then it's obviously going to represent some sort of total. We don't know, probably a total cost, right? Wouldn't you agree with that? If they had 100% of their trip, then they would have the whole thing, the total. So the whole cost of their trip is the total. Does everybody understand that? Yeah. Okay. Now, what you always do after you kind of get this all set up and you've read through it and you've identified the important factors, the important pieces of information that you have, you're always going to identify what the percent is. That is 60%. Does everybody agree?
Yeah.
Okay. I need to ask myself now, I need to somehow cut this strip diagram up into one of these three right here, or those four I mean. I need to cut my strip diagram into one of those. So I need to figure out which one is going to allow me to be able to see, okay, it would be 2 pieces for 60%, or it would be 5 pieces for 60%. How do I want to cut my strip diagram up? What do you guys think? Yeah.
By 25%.
Okay, so Abid said 25%. So let's all think about it real quick. First of all, can I cut a strip diagram into 4 sections of 25%?
Yes.
Absolutely I can. Now, remember, the whole point of the strip diagram is for me to be able to look and be able to see exactly how many sections would represent 60%. So I see 20%, right? Or 25%? I see 25%. That's 50% combined, right? So where would 60% be? Right there? So can I do that? Would this be the most effective way to cut my strip diagram up then? No. No, I wouldn't want to cut my strip diagram in this case up by... Okay, what do you think would be better than cutting it by 25% sections? Steve-O?
20%.
Absolutely. So let's do that. 20% sections. And they're not perfectly even, but they're close enough. So that's going to be 20%, 20%, 20%, 20%, and 20%. Okay. Now, can I tell exactly where 60% is now?
Yeah.
So how many of those sections is 60%? Lucy? 3 of them, right? Okay. All right. Now, I'm going to go ahead and do this in a different color. So what percent do I not know? 40%. Okay. Here's my question that we're going to do into clickers. I want to know whether you think this, I think we would all agree that 4,500 is representing one of 3 things. It's either representing what's in green, or it's representing what's in blue, or it's representing the total. Okay? That's what I need, that's what I want you to do. So, if you think that $4,500 is representing what's in green, you're going to type A. If you think that 4,500 is representing what's in blue, you're going to put blue. If you thought it was the total, you're going to put letter C. Go ahead and do that now. Okay, so we got them in here. Let's see how we did. So we have, what is that, 12 or 11 up there?
11.
11 of you think it is the green section. We have some. So as you can see, it's pretty spread out. So, I'm not even going to put the right answer yet. Okay? Now, this is where we got to be really careful readers. Okay? It says the band has saved $4,500. Does everybody agree with that?
Yes.
That's the amount they saved. That's why we highlighted saved up there. Now, how much do they need? Well, what section would be representing how much they need? Wouldn't it be the blue section? Huh?
Yes.
So, look what it says. It says they've saved $4,500 for their field trip. This accounts for only 60% of the total cost. So, do they have the whole cost yet?
No.
So it can't be a whole. For those of you that put C, and there was quite a few of you that put C, that can't be right? Because they haven't saved enough. They have saved that much. That's only 60%. In order for their trip to be completely, entirely paid for, they would have had to have saved 100%, right?
Yep.
Isn't 100% the amount that they've saved? Okay. So, obviously it's not C. Now, we know that they have saved 60%. So doesn't that 60% go with this amount here?
Yes.
Yes, it does. So therefore, the correct answer would be letter A. Okay? Obviously, it's going to be this amount because it says they've saved that. It is that amount. So wherever there's 60%, that would be your $4,500. Do you guys all understand that?
Yes.
We do not know this. This is what we need to know right here. If we can figure this out, then we can figure out this. which is ultimately what we're trying to figure out, right?
Yep.
We are trying to figure out the total cost of the trip. So $4,500 plus whatever this is, isn't that going to be the total cost?
Yes.
Absolutely. So, think back to bar modeling from chapter 5. What was the whole goal behind a bar model? Who remembers me saying this? And I always did it in a certain color, I won't tell you. Who remembers what the whole point to doing a bar model was? Think back to proportion or to chapter 5. Wasn't it? Yeah.
How many? What's in each?
We need to figure out how much, in this case money, would be represented in one of these boxes. Do you guys understand that? You remember that?
Yes.
Remember how I did it in pink every time? I always did unit rates in pink, and this is kind of like a unit rate. Does everybody agree? How can I figure out how much money would be in each one of these boxes? How am I going to do that? It relates right back to chapter 5. Slammer?
Divide 4,500 by 3.
I'm going to divide 4,500 divided by 3 because I know that these 3 sections right here equals $4,500. And if I know that each section is equal, and I know they're equal because they're each 20%, right? I know it's going to be $1,500 in each one of these sections. Now, that's fine. 1,500 plus 1,500 plus 1,500, that's going to give me 4,500, right? Do I also know that these are 1,500 also?
Yes.
Absolutely. That's the whole point. Okay, that's the whole point to what I'm trying to accomplish here. Can I figure out the total cost of this trip? In other words, can I figure out what 100% of the trip was?
Yes. Yes.
So I can do it 2 ways. I could add the part that they need. They need $3,000, right, guys? If I know how much they need, if I know how much they have, and I add them together, would that give me $7,500? Okay? Okay, the other way you could do it is you could just do 1,500 times 5. Okay, everybody understanding this?
Yes.
Now, real quick, I want to also show you the proportion. Okay, now remember that percent proportion that I showed you at the beginning of class? Does anybody remember what it was? Part over whole equals percent over. That's called a percent proportion. Now, it's a little bit different than the proportions you've done in the past. Because in the past, when you did a proportion, if you had money on top, money was on top. Minutes were on the bottom or whatever, right guys?
Yep.
This is different because now we have a percentage in here. So we're not even talking about real numbers anymore. These were both, all 4 of these were real numbers. Now we have a percent. So you can't have an actual amount percent. That doesn't make any sense. The actual real numbers are here. Okay? So, what's going to go right here in my percent proportion based on my question down here? Abida.
60.
Obviously, the percent's easy to identify, isn't it?
Yep.
Right? Now we know both these labels are going to be money and money, right? This one's going to be the part that they have. This is going to be the total cost. So what do we know? Do we know how much part of the part they have, or do we know how much the total cost is? Brennan?
Total cost. Oh no, how much money?
We know how much they've saved. Remember, this 60% is how much they've saved. We know that they have saved an actual real number amount of 4,500. We do not know this, which makes sense because we did not know this. Isn't that the same thing?
Yes.
Do you see how the proportion comes along on this?
Yes.
Okay, so then we would cross multiply and we would divide and we would still get 7,500. Everybody cool on that?
Yep. Yeah.
All right, let's do another. Okay? Now I'm going to try to erase this in a way to where we can still see the one up there because I'm going to relate back to it. Okay. Let's read through it. If the entire strip, well, first of all, what's the entire strip always represent?
100%.
100% always. It always represents 100%. That's the whole point to it. Okay? If the entire strip represents 60 students, do you think that's important?
Yeah.
Okay. So before I go on, up here, this 4,500, it only represented just a part of this strip, right, guys?
Yep.
Does 60 going to represent just part of it, or is it going to represent the whole thing? It's going to, yeah, it's because it says if the entire strip represent above, or it could be below. Below represents 60 students. So do we know this? Hello?
Yeah.
We know that. We're good. We know that for a fact that it says it right there. So we know if I'm starting to fill out my percent proportion here, I obviously know the percent, right guys?
Yeah.
Do I know the part or do I know the whole?
Whole.
I know the whole. So right there you can solve it like that. But we're going to continue on with the strip. First of all, we always identify the percentage. The percentage. Because it's 60%, how do you guys think I should cut my strip diagram up? Steve-O. I should cut it into 20s. Could I also cut it into 10s, by the way?
Yes.
Yeah.
Sure. That would just be 6 sections would be 60%. Okay, so that's going to be 20%. Notice how I'm writing the percents in here every time. 20%. Okay? Now, this one's an easier one because it's easier when you know the whole, I think. Because then it's like, okay, all 5 of these sections represent 60 students, right?
Yep.
So how can I figure out how many students are in each section? Huh?
Multiply by.
No. Remember, our whole goal is to figure out how many people, or students in this case,
Divide.
would be represented in one rectangle, one piece of the strip. We would do 60, and we're going to divide it by 5, right guys?
Yeah.
Right?
Yeah.
Because there are 1, 2, 3, 4, 5 sections. Therefore, that's 12 students in each section. Okay? Everybody cool with that?
Yeah.
Now, answer the question. How many students would be included in 60%? So how many of these boxes do I need to count up? 1, 2, and 3. So, I'll ask you guys, how many students are represented right there in that strip right there? Bryce? 36. Do you guys see how I did that? If it wanted 80%, would I just highlight one more section? Right? If it was 20%, it would be 12 students. If this said 20 right here. If it said 40%, it would be how many students?
2 boxes.
2 boxes, which is how many students?
24.
24. Now, to go back down to our percent proportion. We knew the whole was 60. We knew the percent out of 100. If we cross multiplied and divided, 60 times 60 is 3,600. Divided by 100 would be 36 students. Makes sense.
Yeah.
I have 36 students out of 60. That's 60%. So this is representing the part that we're talking about, and that 36 goes with the 60. Do you guys understand that?
Yes.
All right. Okay, so here we have 2 strip diagrams. All right. Now we always got to understand some things with strip diagrams. Number 1, what does the strip diagram always represent? 100%. That's the whole point. And then what else is it going to represent then? Is it going to represent some sort of total? One whole, yes, but just a total. That could be a total amount of money, a total amount of dollars, a total amount of students. It can represent anything. Total amount of my basketball players. It's just all of them. The total. Does that make sense?
Yes.
That's what when we draw that big long rectangle, that whole thing is representing the whole, the total. Okay? So it doesn't matter what total we're talking about. I mean, as you can see, we're talking about Skittles, so isn't this going to be total Skittles? Okay. One thing I got students doing, and I just want to correct this right now, because I've seen this throughout the day-to-day. This is the one that's been getting everybody, is I see people doing stuff like this. And I say, how can that thing equal 100% and 60%? Is that even possible? No, that if it equals 100%, then it equals 100%. We can break it into, we can figure out where 60% is by cutting it up, but this strip is always going to represent a percentage, and it's always going to represent some sort of real amount, whether, like I said, students, money, dogs, whatever you're talking about, Skittles. Okay, so let me put that back in. Oh. All right. So we knew that it also equals a total amount of Skittles. Now I haven't even read the question yet, have I?
No.
Now obviously that would come first if you were doing the problem, but I just like to get that out there. Now, if there are 400 pieces of Skittles in the bag, so 400 Skittles in the bag, You think that's important right there? Okay. And then it says, how many Skittles did you eat if you ate 60% of them? So here's my first thing. Did I, if that's me I'm talking about, did I eat the whole bag of Skittles? No, I ate 60% of them. So I ate a little bit over half of the Skittles, right? All right. Now let's think back here, to go back to this page. These are the only 4 methods you can cut up a strip diagram that we're going to use anyway. Okay? You can cut it into 50-50, you can cut it into 25-25, 25-25, you can cut it into 5/20s or 10-10%, right?
Yep.
Okay. Now, if I were cutting this into 25% sections, let's say I did the one we're talking about, the question we're talking about. Now we know the percent that was given was 60, right? Right?
Yep.
Okay. So that's 60. Would you be able to tell where 60% is on the strip diagram? You would? That's 25. That's 50.
Well, not really.
No, you'd only be able to tell 25% of the Skittles, 50% of the Skittles, 75% of the Skittles, and obviously 100% of the Skittles. That's all you could tell. Now, sure, some of you might say, well, what? It would be about right there. Well, it would be, but that's not the point of the whole thing. The whole point is to break it into evenly sized sections, right?
Yep.
All right. Remember, the whole goal of a strip diagram is to always be able to determine what one is. And again, it's always going to be some sort of percent. So for this one, we know that one would be 10%, and we know that it would be some amount of Skittles or some amount of dollars or some amount of whatever we're talking about, whatever the item is. Okay? Cool?
Yep.
All right. So it's always going to have both things in there. How do you guys think, since this is 60% is given, how should I cut this strip diagram up? Who can tell me? Yep.
It's 20%.
I would cut it into 20% because I know if I look at this right here, that's 20, that's 40, and that's
60.
so I know that 3 sections make 60%. So I could see exactly how many sections I need for 60% would be 3 of them. Okay? If I were doing this one, would that be 60% also?
Yes.
Sure. So could I use either one of these?
Yes.
Yes, I could. So going back here, I'm going to cut this thing into, you could do either one, but I'm going to cut it into 5 sections of 20%. Now, notice, I'm always going to put my percentages in here. And I always put the percent sign there. Some people skip that. That'll get confusing because you're going to have another number in here. You got to keep all your labels on there so you don't lose numbers. Okay, now, really what this really comes down to. Now we can go ahead, before I do that actually, I'm going to go ahead and highlight 60%. Is that cool?
Yeah.
Now, what did I do with 60% of the Skittles? I ate them. So, if you want to make like a little key here, and you want to do this and say, okay, I know I ate 60%, then that's all good. Okay. And then if you even want to go a step farther, if you have highlighters or colored pencils that you want to use, and then you would want to say, okay, this would be what then?
The leftover.
Leftover. So left over. Do you guys understand that?
Mm-hmm.
If I've eaten 60%, that means that the 40% that remains must be still in the bag. Or someone else ate them. Because I only ate 60%. Is everybody with me so far?
Yes,
Okay,
sir.
good. Now, really what this comes down to after you've broken this down is you have to be able to figure out, and this is the hardest thing about this, I believe. I think this is what makes this challenging. You have to figure out whether that 400, the 400 Skittles that because they told you there were 400 Skittles. You have to figure out if that's representing the whole entire strip or if it's representing just part of the strip. That's really the question you have to answer, because if you don't know that, you can't really, there's no way to be able to figure out how many Skittles are in each one of these little sections. Okay? Does that make sense? If you thought that their 400 was the part, let me erase this just so that I have more room. If you thought 400 was the part, then you're going to do this, and you're going to put 400 there, and then you'd be dividing it by 3, right, guys?
Yep.
Because that 400 is only representing that. But that's where you got to be real careful. This is what makes it challenging. I'm not even going to lie to you. It's kind of difficult. So what do you guys think? Do you think that this 400 is representing just the green section, the blue section, or is it representing the total, the entire strip? What do we think here? Yeah.
Entire?
Who agrees? Raise your hand. I would agree. Yeah, absolutely. It absolutely, because it says if there are 400 pieces in the bag of Skittles, how many Skittles did you eat if you ate 60%? This right here is representing what?
40 Skittles.
The amount you.
400. 8.
It's the amount you eat. Oh boy.
Yeah, 8.
The amount you ate, right? This is the amount that you have left over or remaining. So did I get any real number about how many are left over or how many that I ate?
No.
Did I get any information on that besides a percentage?
No.
No, I did not. So therefore, I know that this whole strip represents 400 Skittles. Now, if you wanted to do something like this and do another bracket, I don't care how you guys do it. Okay, I don't care whether you put equals 400 total. I know that this down here is the way you guys told me your elementary teachers did your bar models, right? Mm-hmm. Some did, some did. It doesn't matter. However you understand it, but the whole goal is just to understand that that entire strip, all 5 sections right there are 400 Skittles. Okay? All right. Now, when I look at this, I say, okay, I have 400 Skittles. So how am I going to figure out? Well, I don't want to get ahead of myself. What's the whole goal of a bar model again? Yep.
To find the amount of per one.
We need to figure out the amount, both numbers in one of these little pieces. So I already know 20%, right? We've already figured that out. Everybody agree?
Yeah.
Yep.
Everybody knows that 20% is in there. But remember, every strip is gonna have both a percentage and a real number amount. And in this case, a real number amount of Skittles. How am I going to figure out how many Skittles are in this one section, which then I can fill it and make that for every piece? Yep. I'm going to do 400 divided by 5 because look, I took the 100%, I broke it into 1, 2, 3, 4, 5. 100% divided by 5 is 20%. So I'm going to do that same thing with my actual amount of Skittles. I'm going to do 400 divided by 5, and I'm going to get 80 in each little section. Okay? Now you have it all done. It's basically done now. Okay? If I would have told you guys I have only eaten 20% of the Skittles, how many Skittles did I eat? Taylor? If I've eaten, Oh. If I've eaten 20% of the bag of Skittles, how many Skittles did I eat? 80. Absolutely. If I would have eaten 40% of those Skittles, 80. 160 Skittles. If I would have eaten 60%, which I did, I would have eaten, Tyler?
240.
240 Skittles. So that's why the answer is 240. Is that making sense now, guys? Okay, it gets easier as you go. It's just kind of complicated getting it all set up. I know that. But it really helps you to understand the why percents are partials. Okay, now, what is this thing called again? Yeah, but I gave it a special name when we have this situation.
Percentage.
It's a percent proportion. Now we know that all percent proportions are part out of whole and part out of whole. Now the percent's easy to identify because it has a percent sign, so 60 is going to go there. And then all you have to do is, was that 400 representing a part? Does it go with the 60 or does it go with the 100?
100.
Goes with the 100. There's 400. We would cross multiply and we would divide. That would give us 240, just like it gave us there. See how that works? Okay. Now notice this one, we got a whole out of this, right? We'll go down to the next one real quick. This one won't take as long. Okay. Now this one, well, first of all, what's the whole strip represent? 100%. What else does it represent? Don't give me a number. I don't want to know numbers. Yep. Total, in this case, what are we talking about? Total what? Total cost, right? Yep. Okay. We got your total cost here. So we know it equals 100%. We know it equals some sort of total cost of that laptop. So I like to write it in here just so I have it. Because that's what it means, right? If Olivia had if Olivia had 100% of her money she needed, she'd have it all, right? Okay, so I see that she has saved $460. Okay, so that's how much she saved. We're going to have to ask ourselves here in a minute whether that is a part or whether that is a whole. Does that represent a part of the strip or does that represent the whole strip? We need to we're going to come back to it. Now, it says this is 80% of the total amount she needs. So first off, how should I cut my strip diagram up? Natalia, what do you think? How should I cut it up? If it's 80%, 20s would be perfect. Could I also do 10s?
Yes.
So this one I can cut into 20s also. Okay, so there we go. Notice how I'm putting the percent signs on there. 20%, 20%. Okay, now, I'm going to go ahead and highlight 80%, right? Because that's how I've been doing it, because that's what it gave me, 80%. Right, everybody?
Mm-hmm.
So there's 80% highlighted. Okay. Now, we need to now ask this question right here. What do you guys think? Is the $460 she saved, is that going to go along with the whole strip or the 100%, or is it just part of the strip? Isabel, what do you think? Who agree? Does anybody disagree? Anybody?
No.
Listen. Okay. All right. Cool. Well, good. But I like that you were thinking about it. Good job. All right. It isn't, because here's the deal. Does she have enough money to buy her laptop right now?
No.
No, she does not. So therefore, she does not. We do not know this, do we?
Mm-mm.
So we're trying to find a whole. If we're trying to find a whole, that must mean we know the part, right? So we know that this section right here is represented by $460. That is representing $460. You guys understand that? She has saved $460, and we know that that's 80% of the amount she needs. So we always have to have two numbers in our little strip diagram, right? We need to have a percent amount, and then we always need to have a real amount. Once again, whenever you're doing bar modeling, we know that we need to figure out what one section is. Now, we already know 20%, so we're good there. Don't I need to know an actual amount of money in each of these little sections?
Yep.
How am I going to figure that out? Tasia?
460 divided by
Okay, I'm gonna. This is the two that people get. What do you guys think? Is it going to be 460? Who thinks 460 divided by 5? Go. Okay, who thinks 460 divided by 4? Okay, here's the deal. For you three that thought it was 5, here's why 5 is wrong. If this $460 represented the whole strip, or it was the total cost, you would divide it by 5. But because 460 is just how much she saved, which is 80%, 460 only represents these 4 sections, 80% of the strip. Make sense now? Taylor? Does that make sense? Okay, so we're going to do 460 divided by 4. That's going to be 115 in each little section. Right? Now, what is the total cost? That was the other thing. For those of you who thought it was divided by 5, it would have to be a total. And if it's asking for a total, then it must have given you just a part of it. It's another way to kind of figure it out. Okay? So, there's 2 ways to go about this now. You can either just do 460, the amount she saved, plus what? 115 to give you 575. Or, could you just do 115 times 5?
Yep.
Or just add 115 that many times, that's fine too. Okay, now if I'm doing my percent proportion, this is what it would look like. Remember, part to whole equals percent over 100. And I know the percent is easy to identify because it's right there. It has a percent sign by it, right?
Yep.
Now, is that 460, is that representing the whole or the part? Yeah, it goes along with this part because 80% is the amount of the laptop she saved. So we want to know the total cost. See how it all goes the same, guys? Part and whole. It's all about that. Cross, multiply, divide, you'd still get 575. Make it more sense?
Yep.
Okay.